Real numbers. Introduction. We already know various types of numbers. For example, natural numbers 1, 2, 3 and so on. Whole numbers 0, 1, 2, 3 and so on. Integers infinity to -3, -2, -1, 0, 1, 2, 3 and so on. In this class, we will learn about rational numbers and irrational numbers. Rational numbers. A number which can be written in the form of p by q, where p and q are integers and q is not equal to 0, is called a rational number. You may notice that natural numbers, whole numbers, integers can be written in the form of p by q, where p and q are integers and q not equal to 0. Example, -15 can be written as -15 by 1. Representation of rational numbers in number line. Example, represent 5 by 3 and -5 by 3 on the number line. Solution. Draw an integer line representing -2, -1, 0, 1, 2. Divide each unit into 3 equal parts to the right and left side of 0 respectively. Take 5 parts out of these. The point on the right of 0 represents 5 by 3 and the one to the left of 0 represents -5 by 3. Note, one of the rational numbers between two rational numbers a and b is a plus b by 2. Example, find two rationals between 3 and 4 by mean method. We know that one of the rational number between two rational numbers a and b is a plus b by 2. Here a is equal to 3 and b is equal to 4. So 3 plus 4 by 2 is equal to 7 by 2, which is in between 3 and 4. That is 3 less than 3 plus 4 by 2 less than 4. If we continue the above process, we can find many more rational numbers between 3 and 7 by 2. 3 plus 7 by 2 is equal to 6 plus 3 by 2 is equal to 13 by 2 is equal to 13 by 2 into 2 is equal to 13 by 4. So 3 less than 13 by 4 less than 7 by 2 less than 4. Decimal form of rational number. Example, find the decimal form of 2 by 3. Solution. 3 divided by 20, we get 0.6666 to infinity. Therefore, 2 by 3 is equal to 0.666 equal to 0.6 bar, where the bar represents the occurrence or the repetition of the digit. Example, express 1.62 bar in the p by q form. Solution. Let x is equal to 1.626262 and so on be equation number 1. Multiplying both sides of equation 1 by 100, we get 100x is equal to 162.62 6, 2, 6, 2 and so on. Let us assume this as equation number 2. Now, subtracting equation 2 from equation 1, we get 99x is equal to 161. Implies x is equal to 161 by 99. Therefore, 1.62 bar is equal to 161 by 99. Note, the decimal expression of number either terminating or non-terminating recurring. Irrational numbers. A number which cannot be written in the form of p by q for any integers p, q and q not equal to 0 is called a irrational number. These are denoted by capital S or capital Q. The decimal expression of a irrational number is non-terminating and non-recurring. Example, root 3 is equal to 1.7320508075689689 and root 5 is equal to 2.23606797749998. Here, we can see that no number after the decimal is recurring. That means it is non-recurring. Note, if n is a natural number other than a perfect square, then root n is an irrational number. Example, root 2, root 3, root 5, root 6, root 7, root 9 and so on are irrational numbers. Know about pi. Pi is defined on the ratio of the circumference c of a circle to its diameter d. That is, pi is equal to c by d. The Greek genius Archimedes was the first to compute the volume of pi. That is, pi lies between 3.140845 and 3.142857. The decimal expression of pi is non-terminating, non-recurring. So, pi is an irrational number. Real numbers. The collection of all rational and irrational numbers is called real numbers, denoted by capital R. There is a unique real number corresponding to every point on the number line. So, we call this as the real number line. Example, minus 5.6, root 21, 1 by 5, pi, root 7, 12.5123 and so on. Example, find any two irrational numbers between 1 by 5 and 2 by 7. Solution. To find two irrational numbers between 1 by 5 and 2 by 7, we need to look at the decimal form of the two numbers and then proceed. We know that 1 by 5 is equal to 0.20 and 2 by 7 is equal to 0.285714. Examples of two such numbers are 0.2012011201111 and 0.2411411141114 and so on. Example, write an irrational number between 3 and 4. Solution. If a and b are two positive rational numbers such that ab is not a perfect square of a rational number, then root of ab is an irrational number lying between a and b. Therefore, an irrational number between 3 and 4 is root of 3 into 4 is equal to root 3 into root 4. Since root 4 is equal to 2 is equal to root 3 into 2 equal to 2 root 3. Representing real numbers on the number line through successive magnification. The process of visualization of presentation of numbers on the number line through a magnifying glass is called successive magnification. Example: visualize the representation of 3.58 bar on number line through successive magnification up to 4 decimal places. Solution: the given number 3.5888 is in between 3 and 4. So, we will follow below steps. Step 1. Magnify in between 3 to 4. Step 2. Magnify in between 3.5 to 3.6. Step 3. Magnify in between 3.58 to 3.59. Step 4. Magnify in between 3.588 to 3.589. Now, we will get the given number 3.5888. Operations on real numbers. If Q is a rational and S is irrational, then Q plus S, Q minus S, QS and Q by S, where S is not equal to 0, are irrational numbers. Example: check whether 1. 5 root 2, 2, 5 by root 2, 3, 21 plus root 3, 4, pi plus 3 are irrational numbers or not. Solution: we know root 2 is equal to 1.414 and so on. Root 3 is equal to 1.732 and so on. Pi is equal to 3.1415 and so on. First one, 5 root 2, which is equal to 5 into 1.414 and so on, which is equal to 7.070 and so on. Second one, 5 by root 2. Here we are multiplying 5 by root 2 with root 2 in the numerator and the denominator. We get 5 by root 2 into root 2 by root 2 equal to 5 into root 2 by 2, which is equal to 7.070 and so on by 2, which is equal to 3.535 and so on. Third one, 21 plus root 3 equal to 21 plus 1.732 is equal to 22.732. And the fourth one, pi plus 3 equal to 3.1415 and so on plus 3 equal to 6.1415 and so on. All these are non-terminating, non-recurring decimals. Thus, they are irrational numbers. Properties relating to square roots. If a and b are positive real numbers, root AB is equal to root A root B. Root of A by B is equal to root A by root B if B not equal to 0. Root A plus root B into root A minus root B is equal to A minus B. A plus root B into A minus root B is equal to A square minus B. Root A plus root B into root C plus root D is equal to root of AC plus root of AD plus root of BC plus root of BD. Root A plus root B whole square is equal to A plus 2 root of AB plus B. Example: simplifying the following expressions: 3 plus root 3 into 2 plus root 2, 2 plus root 3 into 2 minus root 3, root 5 plus root 2 whole square, root 5 minus root 2 into root 5 plus root 2. Solution: taking the first one, that is 3 plus root 3 into 2 plus root 2 equal to 6 plus 3 root 2 plus 2 root 3 plus root 6. Second one, 2 plus root 3 into 2 minus root 3 equal to 2 square minus root 3 whole square equal to 4 minus 3 equal to 1. Third one, root 5 plus root 2 whole square is equal to root 5 whole square plus 2 root 5 into root 2 plus root 2 whole square is equal to 5 plus 2 into root 10 plus 2 equal to 7 plus 2 root 10. Fourth one, root 5 minus root 2 into root 5 plus root 2 equal to root 5 whole square minus root 2 whole square equal to 5 minus 2 is equal to 3. Rationalizing the denominator. If the product of two irrational numbers is a rational number, then each of the two is the rationalizing factor of the others. Example: rationalize the denominator of 1 by 4 plus root 5. Solution: we know the identity of a plus root b into a minus root b is equal to a square minus b. So, multiplying the numerator and the denominator of 1 by 4 plus 5 by 4 minus root 5, we get 1 by 4 plus root 5 into 4 plus root 5 by 4 minus root 5 is equal to 4 minus root 5 by 4 square minus root 5 whole square equal to 4 minus root 5 by 16 minus 5 equal to 4 minus root 5 by 11. Law of exponents for real numbers. Now we discuss about laws of exponents to the base of positive real numbers and rational numbers. If a greater than 0 be a real number and p and q be a rational number, then a to the power p into a to the power q is equal to a to the power p plus q. A to the power p whole to the power q is equal to a to the power pq. a to the power p by a to the power q is equal to a to the power p minus q. A to the power p into b to the power q is equal to ab whole to the power p. Nth root of a is equal to a to the power 1 by n. Example, simplify. First one, 2 to the power 2 by 3 into 2 to the power 1 by 3. Second one, 5 to the power 1 by 7 whole to the power 4. Third one, 3 to the power 1 by 5 by 3 to the power 1 by 3. Fourth one, 7 to the power 1 by 17 into 11 to the power 1 by 17. Solution. First one, 2 to the power 2 by 3 into 2 to the power 1 by 3 equal to 2 to the power 2 by 3 plus 1 by 3 equal to 2 to the power 3 by 3, which is equal to 2 to the power 1 equal to 2. The second one, 5 to the power 1 by 7 whole to the power 4 equal to 5 to the power 4 by 7. Third one, 3 to the power 1 by 5 by 3 to the power 1 by 3 equal to 3 to the power 1 by 5 minus 1 by 3 equal to 3 to the power 3 minus 5 by 15 equal to 3 to the power minus 2 by 15 equal to 1 by 3 to the power 2 by 15. Fourth one, 7 to the power 1 by 17 into 11 to the power 1 by 17 equal to 7 into 11 whole to the power 1 by 17 is equal to 77 to the power 1 by 17. Third, if n is a positive integer than 1 and a is a positive rational number but not nth power of any rational number, then nth root of a or a to the power 1 by n is called a surd of nth order. Nth root is called radical sign and n is called the degree of radical. Example, root 2 cube root of 9.
మా వీడియో కనుక మీకు నచ్చినట్లయితే లైక్ చేయండి, షేర్ చేయండి. ఇలాంటి మరిన్ని వీడియోస్ కోసం మా ఛానల్ని సబ్స్క్రైబ్ చేసుకోవడం మాత్రం మర్చిపోకండి. థ్యాంక్ యూ ఫర్ వాచింగ్.